All right, we're going to go ahead and get started. So I'm going to, this is real-time streaming analytics at Ford. I'm Dan Totten. I'm part of our enterprise architecture organization. I manage our analytics and our big data platform in terms of architecture, in terms of what we're trying to build out for one of our key customers, which is our global data insights and analytics team. I also have a couple people, and we are going to do this. We actually have a live demo. So we have a couple people on the phone, and I want to go ahead and turn it over to Joe Nemec and Tom to do a quick introduction.
Hi, Joe Nemec, System Architect at Hortonworks. I sit with Ford as their resident architect.
Tom Ryans, Manager of Data Services at Ford.
And on the phone we have two of my team members, David Hickey and Tommy Young, and they are actually back in Dearborn, Michigan. And so they're going to actually be driving a vehicle. They'll be in the vehicle driving around so we can actually kind of highlight the key capability of the platform that we built and rendering it in terms of you can see how the data is flowing through in terms of this architecture. So Dave and Tom, you want to do a quick introduction?
Yeah, hi, this is Dave Hickey. Again, I work for Dan Totten at Ford. We've been building out this real-time streaming analytics platform for just a little less than a year, and we think this is early days for our platform, but we're proud of the progress we've made, and we're looking forward to showing it to you.
And this is Tommy Young. I work for Dave and with Dan, and I'm actually sitting in my car right now out in front of Ford World headquarters, and we'll show you a bit more about that here in a minute.
All right, we're going to go ahead and get started then. So really what we're going to try and cover is really what was the original problem statement. This is, we wanted to really get into the tech side of it, so we have to tee it up a little bit in terms of what we started with in terms of just even less than a year ago. Our architecture components, the data journey that we've kind of gone on here, challenges. We're going to get into that live demo real quick. I want to kind of go through a lot of these slides of events, turn it over to Dave and Tommy so you can really kind of see what's happening with it. And then we also have built out essentially what we've proved and what's happening today, and then in terms of our roadmap, in terms of Ford, in terms of how we are actually going to be able to leverage it for other types of situations and other types of use cases. We think we found quite a few for us. So really when we started this, we actually started it with the idea of some experiments, and in those particular experiments we had what we called our big data drive. And these were items that were some of the experiments that Mark Fields a couple of years ago kicked off in terms of experiments that we could actually accomplish internally at Ford to be able to prove out capabilities in technology. This one here was really tied to what I just described as our big data drive. We had no platform essentially to do streaming experiments. And then how do we enable self-service streaming from that aspect? So we built a team that was an accomplishment of both our analytics, our data scientists, IT, business to try and come up with what those missions and visions were. Utility ingestion, so our existing storm that we have today with our connected vehicle platform would not scale operationally the way it had been implemented, so we needed to find a different technique, and that was really driven from the big data drive experiments in terms of what they wanted to accomplish. Today applications develop their own one-off ingestion solutions, and ingestion solutions to deal with proxy and firewall rules. How do we reduce the surface area that is exposed while handling multiple types of ingest? So what this kind of highlights in the SCA-V, so that it's called SCA-V, it's a single, complete, actionable view of the vehicle. So that's really what that acronym is. I just mentioned to you what BDD was. The thing on the left really kind of highlights our pillars. So in the pillar 1, we talk about the collection of data. Under pillar 2, we talk about the configuration, and pillar 3 is essentially about our edge analytics. Now, what we feel those particular pillars allow us to do is really, those enable a number of these. I'm not going to go through each and every one of those bullets, but those particular pillars allow us to focus on different types of, and enables us for doing off-cycle credits, customer specific city solutions, a number of those particular elements. So it's a core. This environment allows us to have those core things that enables this type of capability, and it's why we keep seeing the opportunities for where else we can actually leverage this architecture. So it drives the value across the enterprise today and in the future for us. It's a multi-platform data and analytics ecosystem. So this is kind of what we've been trying to highlight is we've got the connected vehicle, we've got the connected consumer, we've got the connected home. On the right-hand side, we've got some of the key elements of our particular programs inside of Ford. Last year, Tom actually had a presentation on our data supply chain. So we have our data supply chain. We've established essentially a discovery zone that is really a self-service area for building out analytics. We also have a landing zone where we've been landing data from all of our transactional systems, third-party feeds, as well as the vehicle. And those are the particular programs that it supports. The SCA-V, the SCA-C, which is the same aspect, the single complete actionable view of the customer, just like we have a single complete actionable view of the vehicle, and then other aspects of that in terms of data coming through. So one of the key things that really this allowed us to do in terms of accomplishments, and this was a highlight that as we started building this out, if you really look at what the arrow kind of points out, we created the first real-time streaming application in the enterprise. So it allowed us to really be able to have that ecosystem to send data, do analysis in real time with this particular architecture. So with BDD, we actually created a cloud agnostic, Ford-owned and managed real-time streaming solution. That was really important for us in terms of being able to allow us to have that flexibility as we look at other types of ingest methods and other aspects of the data that we're receiving, whether it's from plant floor, whether it's from the vehicle, or whether it's from transactional systems. This architecture allowed us to do that, and it's something that we felt comfortable that we would be able to build, manage, and support ongoing with a lot of flexibility going especially into the future. So a year ago, we had sort of this twinkle in our eye in terms of, we've heard of the Lambda architecture, but this is really where we started with our big data drive team, was the idea that how could we actually solve for these problems? So we obviously we already had a batch layer. We've been an HDP solution for a while. We had our batch solution available, but we needed to be able to get the data in more real-time solutions. So this is where we started a year ago, and David Hickey, who's on the phone, actually about this time started on my team about this time last year. So in a very short period of time, essentially by October of that next year, less than 6 months, we were streaming data with this particular architecture and refining it with the experiments that we had in front of us. So really in a very short period of time, we went from this conceptual view into really what became our real-time streaming analytics solution. So with this, I'm just going to kind of walk you through conceptually what it is. This is kind of the data journey that we described in a conceptual view, where we talked about the first step was obviously real-time streaming data ingested, routed, and transformed. In the second aspect of it, we had an analytical apps consuming and producing data in real time in that speed layer. And then 3, we passed data into the speed layer to the batch layer. So we wanted to make sure that we had the same capability. So we've essentially mirrored this going forward in terms of going from our cloud solution into our on-prem HDP. We also had historical data that we could analyze, so we could turn the data scientists into that and be able to train their models that would be deployed later on in terms of the edge analytics. And then we had, and obviously said that 5 was training those particular models. So we were trying to address the analytics, the apps, the speed, and the data in terms of how that was coming through. Now, this is where we're going to go ahead and I'm going to turn it over, but I'm going to do a little bit of explaining, and then Dave and Tommy will grab the WebEx, and then they'll walk you through what we've been looking at. So from that conceptual view, now we go into essentially what our platform starts to look like. So as Dave and Tommy will kind of walk you through this journey. Before we do that, there's a couple of key things I want to point out, which is really if you look at the dotted line above that in terms of public internet and the cloud, you have NiFi, and then you have NiFi in terms of the on-prem. That before was really where we had Storm. And so Dave will take you through the journey, but Joe wants to kind of explain a little bit of the benefit that we received by being able to do NiFi on the cloud as well as NiFi in premise and data centers.
Sure. So one of the things NiFi has is that it supports site-to-site capabilities through a proxy as a first-class citizen. If you'd seen numerous presentations from me and Chris Gambino last year, you would have seen us doing a lot of site-to-site kind of work. But a significant number of the problems that we had originally with Storm, as Dan had alluded to earlier, were operational in nature, right? So we were having problems with Storm's inability to natively connect through a proxy for us to reach out and be able to resolve host names in the cloud. And that added a lot of extra work to our operations team ability to scale out to new endpoints that we needed to ingest over time. So we really wanted to have one consolidated method, right? One mega pipeline or digital pipeline that all data was going to flow through back into the data center from the cloud, and then potentially in the future also be able to be bi-directional so it could send it back, right? So other benefits that we got from being able to just do NiFi to NiFi was originally our data that was egressing the cloud coming into our data center was not compressed at all, right? So we immediately got cost savings by being able to compress this data as we pull it in. That also increases throughput potentially because now you're able to shove more through the pipe faster. It has delivery receipts, right? TSL encryption. So you're able to effectively set up a system where you can limit that surface area to only the specific hosts that are on your WAN and the hosts that are out there on the public cloud that run your NiFi site to site so that only they are allowed to communicate, giving you a much more secure channel on top of the encryption and so forth. And then the other thing that NiFi has really enabled us to do that Dan had related to self-service streaming on a slide was how do we take that fire hose of data that's coming from number one there and making its way into a system like Kafka and then be able to peel off specific garden hoses of that data, right? If it's GPS related or just breaking data or just airbag deployments, and route it back into a topic dedicated to that that's gonna power an application that doesn't care about the entire fire hose of data, but only cares about those very specific elements or features that are related to the model that they're implementing.
So what we're going to do is, we're going to turn it over to Dave and Tommy. They're going to walk you through this. But how many of you guys are familiar with Carpool Karaoke? You've seen that show? So I tried to get Dave and Tommy to actually kind of act as if they were going to do the Carpool Karaoke, but that didn't work. So they're just going to walk you through this. So Dave and Tommy, take it over from here. Or do I need to go into the? Got it.
Yeah, no, we're here, and I'll sing. Tommy's got to drive. But he's got a better voice than me, so maybe he should be the one singing. Can you guys see the screen okay?
No, do not.
David, you need to share. You're not sharing at this point, so.
You know, I always have problems with sharing, don't I? Here we go. Let me share the screen. And you guys let me know how this looks. Right, there we are. Can you guys see that okay?
Yeah, hold on. No, hold on a second. I'm still in the.
No, just go in, click escape. In the vacation pictures. Okay, now go back to your WebEx.
There we go.
Yep. Looking good?
You're good.
We're good now.
We're good?
Oh.
Okay, cool, cool.
No, hold on.
So, all right.
As soon as I went out of that, it.
No, that was him.
That's you, David?
He has the same.
That's me. Yeah, that was
Okay,
our
got it.
seamless transition, right?
All right. There we go.
All right. Cool. Hello, everybody. Again, this is Dave Hickey and Tommy Young back in Dearborn. And what we're going to do is we're going to take you on a little trip around the campus of Dearborn, Ford's headquarters. While we're doing that, where the data that's being generated off of a 2015 Ford Explorer is going to take a little trip as well. And as Dan was talking about and Joe were pointing out, this is the high-level architecture for our real-time streaming analytics platform. And so it's sort of in the following order, steps 1 through 5. We've got a vehicle right now that's driving around the campus. It's got an OpenXC vehicle interface plugged into its ODB2 port. Attached to that is also a Raspberry Pi. That Raspberry Pi is running a stack of software, primarily Python and a number of necessary libraries to interface with the CAN bus on the vehicle. And we're essentially pulling all of high-speed CAN 1 off of the vehicle live, full volume off of the vehicle. And what we're doing is we're then sending that data into our cloud infrastructure. We're connecting to a Cloud Foundry-based Spring Boot application. It's a WebSocket endpoint, and that WebSocket endpoint immediately forwards the data into a Kafka topic. where it's subsequently being consumed by applications. We're also using NiFi to consume that data to send it back down into our data center, like Joe alluded to, and where it's also available for consumption either in a real-time mode or ultimately back into long-term persistence in HDFS, where our data scientists are looking at all of our historical data. So this is the map that I'm going to take you through, and there's going to be 5 steps, and each step along the way I'm going to show you something kind of visual. It's sort of like a dashboard, if you will, on steroids, but you'll get a sense for how this thing works. So I just flashed over to our crazy dashboard. What you see in the center is what looks like, you know, a typical dashboard where we've got speed, we've got RPM, we've got fuel level indicated and some gauges up at the top. We've also got a dynamic map at the bottom, and you can see where Tommy's been all over the place in Dearborn. And every time he moves his vehicle, this is updating, and we're keeping track of his location via GPS. What I want to show you, though, and the reason I've got these other screens up and running is really to impress upon you the idea of the volume of data that's coming through and at the velocity that it's coming through in. So this first box up in the left-hand corner really represents that first stop that I was talking about. We've got a WebSocket Spring Boot application, which is running in Cloud Foundry in our Azure environment, and this is the ingest point. This is where the vehicle, the OpenXC VI, the Raspberry Pi are making a connection to a WebSocket endpoint, and it's basically pushing its data through. And I'll just make this bigger. So you kind of get it. It's not real readable. We'll show you something that's a little bit easier to read in a few minutes. But basically what this is a log, and it's just tailing the log of that WebSocket endpoint, and we're just spitting out the message. And I can stop this for a moment so you can see the raw message has been, and I'll restart that, and then I'll shrink this back down. But that's really what we're doing there. Step 2 is kind of interesting in our infrastructure, because once the data has been pushed into Kafka, and by the way, this is the raw data being displayed that's being pushed from this WebSocket endpoint into a Kafka topic. And this is our raw CAN bus data. So it hasn't been decoded, it's in a binary format. I'll stop this. You can't really read it because, again, the data's in a unencoded format, but I'll resume that. I've got my Kafka console consumer going. I'll get that going again. But what we've got here, which is kind of cool, is we need to decode that to make it human readable. We got to be able to parse the data and use it for some analytics downstream, whether it's a real-time application that needs to use that information or whether it's something that we do in the batch environment. So step 2, I'm going to show you, is where we've got another Spring Boot application, which is consuming that raw data out of the raw Kafka topic. And basically what it's doing is it's decoding it. Tommy Young gets to take a bow for writing the program that's doing this. And essentially it's decoding that raw data, and what you'll see here is something that's a little bit more human readable. We've got CAN signals that are being sent in JSON format. Again, not real easy to read. I don't expect you to memorize or look at this and draw any intelligence out of it. We'll show you something in a little bit that'll help with that. But I think you get the point. We're on the fly. We're decoding that data. We're passing it through the infrastructure. I'll get this Kafka topic or consumer going again. And you can see this is all happening on the fly. As we're driving. So far we've gone from the vehicle. You've seen over here the blue where we've got the WebSocket endpoint. It's consuming that data that's coming in through our 4G cellular connection, by the way, that we're making via the Raspberry Pi. That raw CAN data is being put into a Kafka topic. And immediately we've got another Spring Boot application which is consuming that raw CAN data, and it's responsible for decoding the raw CAN data and putting it back into a new topic or an additional topic where it can then be pulled down via NiFi into our data center. So we've just hit a couple of big steps there. Again, we're doing all of this right now in our cloud environment, and we're about ready to send the data back into the data center. So the next step is to show you NiFi, which, by the way, let me just back up a moment. I haven't really showed you NiFi yet. I think you're probably interested in seeing that. So I'm going to step away from this, and I'm going to go to a screen where we can take a look at our NiFi canvas. If it'll let me do that, there we go. So we've got two instances of NiFi, as I think Dan pointed out. We've got an instance in our cloud infrastructure, and then we've got a NiFi instance running in our on-prem data center. So this just happens to be a very simple canvas that's running in our cloud, and it's basically, you can see here by the labels, we're consuming data out of a Kafka topic, and we're doing some downstream processing on that data. We're adding some value. We're adding some attributes to the data so that we could then properly manage the data once we want to store it in HDFS and put it into appropriate directories. So some very simple light data enrichment processing going on in this step. And then we go to an output port, basically. We've got an output port on the canvas, which is allowing us now to take advantage of that great site-to-site capability that Joe talked about and send the data down into our data center. So I'm going to toggle now over to a canvas that is running in our data center. And what you can see here is we're getting the data back from that cloud-based instance of NiFi. And we're doing a lot of work here. I'm not going to take you through this canvas, but you can see here, there's Tommy's driving, he's generating a lot of data. And we've got a lot of data queued up, it's being processed. We're doing some grouping and some merging, obviously, for some efficiency here in the way we're landing the data. But ultimately, the data needs to get down into HDFS, and that's what NiFi is doing quite nicely for us here. So again, this is the on-prem version of
Hey, David. Hey. David, you're starting to break up a little bit.
How do I sound now?
Much better.
Yeah, okay. So here we are in NiFi. Let me back out for a moment here and take you guys back to where we're at with our roadmap. So we basically just kind of took you down into this step of the trip. So now that we're down into the data center, we have an equivalent stack of technology and software running in our data center. We have Kafka. We have a number of tools that could be used for analytics against the data. And what Tommy and I happen to be using right now for our own purposes is a simple user interface that I was showing you, and I'll go back to that right now. Let's toggle back over to that guy. And so this is a Spring Boot application that is running. Again, this was running up in our cloud infrastructure, but you can see we're tracking Mr. Tommy as he's driving through the streets of Dearborn. And every time one of these new markers show up, that shows progress that he's made. And it looks like he's driving around the Ford campus here. He was at World Headquarters. You see the Southfield Freeway, and he's running around the building here that we call home.
And those markers are actually refreshing at about 5 seconds. So
yeah, about 5 seconds. We've got another version of the UI that's kind of hot off the press that we probably could show right now because it's I think we've got a couple of minutes here, but whoops, sorry about that. There's bear with me. Here we go. It's a similar kind of thing, but it's more of a heat map, and this one's refreshing just a little bit sooner. So we're taking advantage of some really cool data visualization APIs that Google makes available to us here. So it's basically the same dashboard, but now with just a different type of a map, and it's a heat map. So you can see where Tommy's spending most of his time, parked outside the office here. He was up at World Headquarters for quite a while, and parked there. He went around the Ford Credit and Ford World Headquarters campus. And if we zoom in just a little bit and switch over to satellite mode, it might. So kind of cool. And this one's refreshing a little bit more frequently. The focus is always on the most recent data point, which is why every time I drag it down, it wants to go back. So anyway, but the point I was making is this is a real-time app that we've built off of the stream. We're using Kafka. We're consuming this data real time, and we're making it available through a very simple user interface that's consuming that data real time. Any questions so far?
Yeah, I think what we'll do is we're going to keep Dave and Tommy on the phone. Dave, it's going to be hard to do questions, so if you guys stay on, we'll get through the rest of the deck, and then if you guys have questions, I'll obviously have to repeat it so you guys can hear it from the audience. So
yeah, let me get to the point where we're landing the data now in Hadoop, and that would be kind of here in our journey. Let's go down one, and we've got everything. I'm going to get everything kind of back to where it was so you guys can keep perspective on what's happening here. So now finally, we want to see the data that's landing in Hadoop. And this is the way it looks. And I've already got this one set up. So you can see I'm going to go into the directory structure where the data is being stored. And NiFi is storing that data. We've got roughly fairly equivalent chunks of data as a result of that merge processor to collect all of the messages and put them in a file and send the data down into HDFS. I think we've got it scheduled for every 15 minutes right now. But again, those are configurable properties.
Actually, we're writing data files that are just under 128 megabytes, so we maximize the HDFS block.
Yeah. And there's some best practices around how to do that and why you do that. And I'm going to show you what one of those files looks like that just landed. And again, you're looking at it and you say, okay, great, that's a bunch of JSON. It's got some canned signals. It's got message IDs. It's got all the values, all of this rich stuff that's coming off of the vehicle, all of the ECUs and all of the chips that are on board. But you need to analyze it ultimately. So we're storing it in HDFS, and our data scientists have access to a myriad of tools. Tommy and I have been tinkering with something that's kind of simple, and it's Excel. So we've got a pivot table here right now that's showing historically one of the drives that Tommy had taken previously about a week ago. And basically just giving a trip summary. It's giving the fuel level. You can see he stopped for gas right here. He refilled his tank. And the number of miles driven on each of the trip legs is being displayed here. The average speed, minute by minute. We could drill down to the second level if we wanted to. And again, this is a pivot table. We're using Microsoft Analysis Services to build an OLAP cube against the data that's being stored in HDFS. So it's a really, really cool way to get the data into an environment where human beings can actually start doing some analysis and start creating some hypotheses or thinking about some of the things that they want to explore from an analytic standpoint.
all right.
And that is how we're reading the data once it's in HDFS. So I think we just kind of took you through the full trip. And let's see where Tommy's at right now. Let's check on him. Any questions?
Yeah. All right. So what I'm going to do is I'm going to go ahead and go to the next couple of slides in here.
Yep.
And we'll do is. All right, so with this one here, this kind of just talks about the kind of the summary of foundation services that David talked about. And again, one of the things I wanted to stress is, we started that conceptual view about a year ago. By October, we already had data starting to stream, and then we kept refining and iterating through this to be able to find out what else we could do to be able to accomplish that. We've got a couple other members in the audience here that have been instrumental in helping us get the architecture stood up, engineered, turned on into production. A couple of things, though, that we were actually started to think about beyond just the vehicle. So one of the things that we have is we have a Cisco Meraki Wi-Fi hub that's actually in one of what we call our New York hub, and it's actually basically it's not a dealership. It's an environment. It's a brick and mortar building that allows people to go in and understand the connectivity of the vehicle. And so we get a lot of foot traffic there. So all that foot traffic is tracked by that Cisco Meraki Wi-Fi. That data is actually streaming through this RTSA architecture that we have. So we leveraged it from that standpoint. So we're finding a number of opportunities to be able to leverage. So we've got the data started flowing on 228 for that one. And then production infrastructure, as I said, we've already got basically stood up from that standpoint. Other opportunities. So beyond that, one of our key challenges that our Chief Data and Analytics Officer, Paul Ballou, said is one of the biggest problems we have today, or biggest challenges, is really manufacturing data. So and that's one of our big data issues that we want to be able to resolve. How do we do that? Well, we started wondering whether or not there was an opportunity for us to actually leverage our real-time streaming architecture to be able to connect actually directly to the machines inside of the plants. We've got a number of applications, real-time applications, transactional applications that do aggregates and everything else, but we wanted to go directly to the machines. So we're right now considering all the opportunities there. We're actually working with another team to do an experiment to be able to connect directly to PLCs and be able to use this architecture to be able to stream that data. It's inside of our Ford network, but it allows us to be able to use the same architecture, to be able to use NiFi, Kafka, to be able to route it and be able to do essentially the time series that we want to do, predictive maintenance on the machines. So we're trying to find, we found a number of different opportunities. It does feel a little endless from that standpoint, but it's been proving itself quite viable for a number of different solutions. And that's pretty much it. So I wanted to leave a little bit of time for some Q&A if you guys have any questions. Dave and Tommy, I'll leave you guys on and I'll rephrase the question or at least repeat the question if it comes to you. Any questions?
What is the scale of cars feeding into the system and also scale of infrastructure that runs this for you guys?
Tommy, so this question is the scale of the architecture and the scale of the number of vehicles that we actually have routing or the amount of volume that's coming off per vehicle?
Or just overall? How many cars are...
How much volume can it handle? So Tommy, you want to take that one?
Yeah, and I'll answer in somewhat vagueness because somewhat it's a competitive thing, but we actually don't know the true upper limits of the architecture because we don't have enough bandwidth to be able to saturate it. But we've simulated several thousand vehicles sending several hundred messages a second each, and with no issues. With Kafka absorbing most of the elasticity of the load because it can ingest really quickly, and then NiFi processes it and gets it down to the data center as it can. But that ingestion point, we can ingest the data and get it in really quickly. And obviously, taking the full CAN bus off of a bunch of vehicles isn't feasible from a cellular data perspective. So it'll start to get cut down, but starting with the full CAN bus lets us give the architecture a good workout without having a bunch of vehicles at once.
Does that answer the question?
Here's on the size of the NiFi. Is it 1, 3, 5, 15 nodes?
So the cloud infrastructure today is 3, and on-prem varies depending on the environment, but it has been smaller than the cloud.
Chris, you have a question?
How do you handle the car identifying itself to your system? Is this part of the payload message it sends in?
So the question is how do we identify the car when it's sending the data, Tommy?
It's by VIN. So we're capturing the VIN is being pulled off of the vehicle, and that's part of the payload.
Okay. Other questions?
What is the use case for the Ford user who rents the car? Is this any architecture beneficial for them?
Yeah, so the question is really what's the benefit to the Ford customer who's actually driving a Ford vehicle, right? So that's where really the big data drive started out, is what could we potentially do to impact customer experience? There's a number of scenarios that we're trying to, this is the experiment that allows us to actually kind of start to reach towards that. It could be related to vehicle maintenance in terms of being able to message that back in terms of analyzing brake wear or other types of aspects. So we're working with our marketing organization to kind of work through those particular things, but we think it's an enabler to get us to that point with the customer. So we're still working through a number
I
of
think I've
experiments.
heard, Dan, it said by a data scientist, a very wise data scientist, that with enough data and some good predictive models, the idea here is that we'd like to predict your engine light coming on before it comes on and get you to a dealer that's closest to you. So it's sort of the vision.
Yeah, so we actually started, what we ended up doing is we actually started with Rabbit. It was just easier for us to stand up immediately. It was something that, as we were working through our architecture, but we always planned on going to Kafka. It was just something that was sort of at our hands a little bit easier immediately. So. Well, right now we do actually, so the question is really around privacy. So right now with that, and we are doing a opt-in strategy specifically for our management lease vehicles that are Ford employees that are trying to go through this. But and we're still working through some of those issues, but an opt-in thing to make sure that we are aware of that and working with our GDI organization to make sure we have privacy covered. We do a lot with encryption. Obviously the payload is all encrypted as it comes across, but those are things that are paramount to GDI and organizations to ensure the privacy. So we're still working through a lot of that.
When are you doing a connected car app?
What are we doing?
What was the question?
When?
When are we doing a connected car app?
We really do right now.
We
have a Ford Pass app out there, and
Yeah.
and so the vehicles that have 4G modems on there, you can do things like find location, remote start, remote door lock and unlock.
Track
and it
your
also gives
fuel
you
economy.
some diagnostics information.
And that's a completely different pipeline from everything you're showing today.
It is.
Okay.
Well, it goes through the same cloud, but it's not NiFi. So it uses Storm.
And that's where the things start to converge, right? That's where we're starting to recognize the opportunities of enhancements to our existing architecture.
So you spoke a little about the what. Can you speak to some of the lessons learned that you guys went through in the 8 months or so?
Yeah, well, there were a lot of lessons. So one of the key things was organizationally, how did we get through traditionally a heavily bureaucratic process organization. And what we did is, that lesson was, we created small, balanced product teams with a very clear direction in terms of what were we trying to experiment. We were trying to create a test and learn ecosystem, and that really allowed us a lot of liberties to be able to, one, like I said, to bring in a team that essentially started just a year ago, to be able to assemble that team. It was about maybe 8 to 10 people, with a clear vision and mission statement, and to be able to experiment. And those experiments allowed us to really then prove out that capability. At each one of our opportunities where we learned things, we were bringing that back to our Chief Data and Analytics Officer to be able to kind of showcase the learnings that we had, and to be able to promote why we needed to be able to put that into sort of a production instance. So a lot of it was organizational, but it was also allowing us to be able to take advantage of the technology in these smaller chunks without having to look at it as these long lead, well, in 2 years I might have this architecture. So we experimented, we allowed to go fast, fail fast, and really move things much faster than we normally would have done.
But from a technological perspective, at least in the Azure cloud, one of the things that we found interesting was we did have a few NiFi nodes that were ext3, and we turned another one into XFS, and we saw almost a 30% performance improvement by going to XFS. So small thing, right, when you're setting up, but potentially big gain.
Do you find that your fail fast, tolerance for fail fast is part of your innovation journey? How well supported is that top down?
Yeah, so it's become part of actually our culture. So actually, Marcy Claiborne now is in a new role. She's actually heading up our entire mobility, GDIA, and IT. And as part of the culture that they're trying to influence is really trying to drive towards customer centricity, building out technology at a much faster pace. So it's become part of our DNA. It's a slow change culture at any organization. You know, if you're changing from what probably is Ford known for versus where we're trying to go, We've been doing that for about a year, and it's slow, but this has been actually influential in terms of kind of proving that you can make those particular changes. And you get pockets of these smaller balanced product teams that are innovating, moving fast, delivering, and that's been one of the things that I think has been really helping speed up that change in terms of the culture.
I think you mentioned single view of the customer, single view of the vehicle, right? Do you guys aggregate those metrics?
I thought I would share the map while the questions were going on, just so we can keep an eye on
That's-
Mr. Young
Yeah,
as
yeah,
he's
we
driving around
do.
Dearborn. You can see he's made some progress, and he's looped around the building a couple times. We'll keep an eye on him.
So
do you have that,
I
Tom?
think the question was, do we aggregate the data between the vehicle and the customer? And that's absolutely we do. So we're looking at we want to get to know our customers, right? And we want to sell more cars to them, of course. But combining the vehicle data with the customer data gets us there into those single complete views.
How do you handle security around PII information?
How do we handle security from PII? Well,
Yes. Want me to take that?
Predominantly, at least within the batch layer of the system, right, we do an anonymization or masking action basically as a one-way hash, right? So if you ever had the VIN and you didn't know what the hash was, all you need to do is actually run the hash with the proper salt and you could go look up in the database. Otherwise, you would have to know what that GUID or that hash was that we had assigned. And there is a lookup database somewhere in the back end that is heavily ACLed.
Yeah, that way, if someone wants to be forgotten, it's one record remove, we're done, right? So if they want to opt out, if they've opted in, they want to opt out and all their data they want to be gone, remove that one record that maps the VIN to the hash,
Exactly, we can
and they're
debug
gone.
So you de-identify on the phone.
Yep.
On the architecture diagram, there was a reference to the boundary. Maybe you can talk about that.
So the beautiful part of the architecture, right, is that really it was about routing, streaming data around, right? And after that, your application can subscribe to that topic, and that could be any application, right? It doesn't necessarily have to be something within the Hadoop stack, right? It could be Cloud Foundry, it could be a custom Java application living on IaaS. And so some of the diagram is meant to represent the fact that now you have an agnostic layer of things that you can attach to the streaming architecture.
Yeah, we get to let the data scientists build. If they want to use Spark Streaming, they can use Spark Streaming. If they want to use anything else, it's ingest, it's routing, right? That's really the core of this architecture that allows that capability.
It's clearly a loosely coupled, platform agnostic sort of implementation.
There's another question over here.
With the on-prem and the cloud setup, are you kind of scaling by scaling up? Are you expecting any kind of bandwidth or hard issues?
So obviously there's lots of projections and planning as far as WAN capabilities go, right? I don't think we need to discuss that. But as far as the cloud goes, our receiving layer, right, is predominantly Cloud Foundry at the moment, right? And that gives us on-demand scaling capabilities based on load. So if Dave or Tommy had actually gone to the Cloud Foundry UI, you would have probably seen as Tommy drove around more and more and did more button presses that it would increase the number of containers dynamically, and then once that load stops, it will drop it back down, right? And we rely on Kafka to predominantly be that buffer at the moment before it gets brought down into the data center, right?
And one of the controls that we put on Kafka and commitments we made to our senior leadership was, you know, we were not going to persist data in Kafka for more than a certain period of time. So usually we look at 24 hours or less to maintain that, and everything else goes into the batch layer. So it continues to flow into the batch layer, but we're controlling that scale of Kafka because we don't want to put too much. We want it to be really in that batch, but at least it allows us for about 24 hours or less. Any other questions? All right, thank you guys. Appreciate your time. Thank you guys.
Thank you.